Hey guys, hoping all is well with everyone. So in this video, I'm going to be going over some practice problems with solving two-step inequalities. So let's just do a little recap here. So remember, inequalities act just like equations. The biggest thing that we want to remember is they act like balance scales. So whatever we do to one side mathematically operational, we have to do it to the opposite side. That keeps the scale balanced, and we always want to keep our equations balanced at all times. Now the biggest things that we're going to be talking about here is just the inverse of what is being done to the variable, and that's going to allow us to fully isolate the variable to allow us to solve for the solution set. Now the reason I say solution set is this is the branch or part of mathematics with inequalities where math doesn't have to have just one answer. Now we're kind of getting introduced to something where, well, x or the variable can be any number of kind of answers as long as it satisfies a true statement. Okay, so let's look at number 1 here. So we have the quantity 2x plus 5 is greater than 13. So again, our goal here is to fully isolate x by what's being done to it. Now, usually in the past, I usually mention how when we're solving equations or inequalities, it's kind of like the inverse order of operations, like your please excuse my dear Aunt Sally. For the most part, that's true, but there's a couple examples in this that we're going to talk about where you don't always follow the exact reverse order. So for this case, we're going to go ahead and we're going to do the opposite of the order of operations first by either adding or subtracting depending on what is being done to the variable in the original equation or inequality. So since 5 is being added, we're going to go ahead and subtract 5 from both sides of the inequality sign. And that's, again, think of it almost like a seesaw too. If you want the seesaw to stay balanced, the fulcrum has to be balancing 2 of the same weight on both sides. So when we do this, we get 2x is greater than 8. What's basically essentially happening here is everything on the left side where the variable is canceling itself out. So if I grab my little pencil here, plus 5 minus 5 is going to equal 0. And then you still need to account for the right side of the inequality, so we get 13 minus 5. But now we know that all we have left is 2x is greater than 8. So we're going to now do the inverse of what's being done to the variable, which is multiplication, by dividing both sides by 2. And when we do that, we get that x is greater than 4, which is 8 divided by 2. And again, what we're doing here is we're isolating the variable. When we divide 2 by itself, any number divided by itself is 1. And then we run into that very common multiplicative property of 1, or multiplicative identity of multiplying by 1, which basically just tells us that anything, variable, constant, number, integer, multiplied by 1 is just itself. So now we fully isolated x, because even if it is 1x, we infer that, and we can just say x is greater than 4. Now here's the very important part of these types of questions. The biggest thing that you want to do is make sure that your solution set works. So what you can do is pick a number that would satisfy this inequality. In this case, any number that's greater than 4. So I'm going to choose 10. What I'm going to do is I'm going to go back to my original inequality and I'm going to substitute in 10 for anywhere that I see x. So 2 times the 10 plus 5 is greater than 13. Now, when you substitute this value in, as long as your value satisfies your solution, as in 10 is greater than 4, then your solution will be a true solution as long as the original replacement of the value you chose also satisfies. So let's go ahead and evaluate this. This is 20. 2 times 10 is 20 plus 5 is greater than 13. Go ahead and make sure you take that extra step just for completeness. 25 is greater than 13. And that's true. That's a true statement, so that's how I know that that is going to work. Okay, so like I said, not too bad. We just want to be really vigilant of each step that we take when we're isolating the variable. Let's look at the next one. So we have, and I apologize, I'm going to be manually putting in the equal part of the inequality just because I don't know how to do that with a keyboard. But let's go into this next one. So we have, actually let's do it this way. Okay, so we have x minus 4 over the quantity x minus 4 divided by 3 is less than or equal to 5. Now, here's where things get a little interesting with what I was mentioning by you want to be careful with your order of operations here. In this case, because the subtraction is part of the fraction, the biggest thing that you want to do when you see rational fractions or any rational numbers in your inequality, you want to get rid of the fraction right off the bat. It just makes your life a ton times easier. So the way you do that is you multiply both sides of your inequality by your denominator. When you do that, multiply both sides by 3. Again, we can do anything to an inequality or an equation as long as we do it to both sides. So what's going to happen here is this fraction is going to disappear because 3 divided by 3 is 1. Now, originally, I can't divide x minus 4 divided by 3, and I can't just add 4 to both sides. The reason for that is that this essentially says x over 3 minus 4 over 3 is less than or equal to 5. Not that this is hard, because you can definitely go ahead and add 4/3 to both sides. You just have to do the whole common denominator thing, and it can seem a little bit more tedious. But when we do this and get rid of the fraction right off the bat, we're left with x minus 4 is less than or equal to 5 times 3, which is 15. Now we've made our lives a whole lot easier, because now all we have to do is isolate the variable one more time by adding 4, which is the inverse of subtracting from both sides. So we're going to add 4 to both sides, and our solution is going to be that x is less than or equal to 19. So let me actually go ahead and put in these solutions here for us. So this is x is greater than 4. This is x is less than or equal to 19. Now again, you can go ahead and check your solution. Make sure it works. Now here's a really cool trick for this kind of solution to check. I'm going to choose 4. The reason I'm going to choose 4 is when I plug in x for 4, when I plug in x for 4, I get 4 minus 4 over 3 is greater than or equal to, less than or equal to 5. 4 minus 4 is 0. 0 divided by 3 is 0. And 0 is definitely less than or equal to 5. There's going to be tricks that you start to notice that help you decide which numbers are really good to test and which ones aren't. I tend to find that if you choose really close numbers, if your solution works, it works. But sometimes the numbers get really close, and then when you start to get into more in-depth multi-step inequalities, you want to make your answer more like well known that the solution works. So let's look at this next one. Let me just go ahead and delete this here. Oops. Okay, so this next one says 5x, actually, we have 5x minus 7 is greater than or equal to 8. Now remember, if you're having a little trouble remembering which side points to greater than, which side points to less than, the way I was always taught is the alligator's mouth is more open at the greater end sign. So the more, I guess, of the teeth that show, the greater the value. Something like that. But this is going to be a case in this question where we're just going to use the reverse order of operations because there's no rational or number or fraction that we have to deal with. So let's go ahead and start by adding 7 to both sides. That's the inverse of subtraction. And then again, our goal here is to cancel stuff out. So -7 plus 7 will cancel. 5x, make sure we're applying the operation to both sides. So 8 plus 7 is 15. Now we're going to do the inverse of multiplying by 5, which is going to be dividing both sides by 5. And we're going to get that our solution set is that x is greater than or equal to 3. Now again, we can check our answer here, and anything that's greater than 3 will be a solution. Now, I'm going to go a little above and beyond here to show you what I was talking about in not choosing close numbers. I'm going to choose 100. If I plug in 100 for x here, I'll get 5 times 100 minus 7 is greater than 8. 500 minus 7 is greater than 8, or greater than or equal to 8. 493 is definitely greater than 8. So you can kind of see what I mean by when you choose values to make sure they work, sometimes it's not a bad idea to just go way out there in whatever direction you need to, just to make sure that your solution works. So it never hurts. So this is going to be x is greater than or equal to 3. Okay. Alright, let's do the next one here. Okay, so this next one, it looks different from what we've done so far, but it's not too bad. This is one where we just want to really be careful because it almost has like, it almost plays by its own rules, so to speak. Oops. And the biggest thing that we talk about when we're playing by its own rules is just the order of operations that we need to follow. So remember earlier when I was saying how that originally in number 2, that minus 4 was part of the fraction or part of the quotient of the quantity x minus 4 over 3. In this one, the plus or the minus operation is not part of the quotient. So for that reason, we can go ahead and do this just as we would by a normal reverse of order of operations. So we'll go ahead and subtract 4 from both sides, because that's the inverse of adding 4. And we'll get that x over 2 is less than 3. Now here's where, again, you want to undo what's being done to the variable. X is being divided by 2. So we're going to undo that by multiplying both sides by 2. And again, essentially what that is doing is it's canceling out the 2's and it's isolating x by itself. So remember, again, we're running into that multiplicative identity of 1. 2 divided by 2 is 1, but we're still multiplying by x. But since anything times 1 is itself, x is now isolated and by itself, which is exactly what we want. And then we just multiply on the opposite side. 3 times 2 is 6. So our solution set is x is less than 6. Okay, if you have any questions about that, let me know. Okay, let's look at the next one here. Oops. Okay, so we have 9x minus 3 is greater than 6. Now here we have no fractions that we have to deal with, so we can go ahead and just use that strategy of reverse order of operations. So addition and subtraction will be first, so since x is having 3 subtracted from it, we're going to add 3 to both sides. And remember, using that inequality or equal sign as your fulcrum of your seesaw or your balance scale. So that's going to tell you what to make sure we mathematically operate on both sides of the inequality here. When we do this, those 3's are going to cancel out, so we'll get 9x is greater than 9. We're going to divide both sides by 9, and again, this is going to allow us to fully isolate x because 9 divided by 9 is 1. Okay. Now, one thing that I have shown you so far in these practice problems that you may see differently somewhere else is sometimes that the inequality or the variable of the inequality is on the right side. There's nothing wrong with that whatsoever. And honestly, when it comes down to it, when you start to see like variables on both sides of your inequality, it honestly just comes down to what's most comfortable for you. Eventually we will have to kind of introduce negative numbers here, and there are going to be some special actions that we have to take, but for right now, whatever side the inequality or the variable is on, don't let that bother you. It means the inequality sign or orientation will be in the direction that it needs to be as to fully represent what x is in relationship to the expression on the opposite side of the inequality. Okay? Let's see here. So, yeah, so number 5 is x is greater than 1. Alright, let's look at this next one here. Okay, so we have 11 plus 3x is less than or equal to 17. Now again, we have no fraction that we have to deal with, and even though the 3x is second, that definitely doesn't matter. One thing that you can do for housekeeping and organizational purposes is if a number doesn't have a sign on it or assigned to it, like a subtraction sign or negative sign, feel free to put a plus sign here. There's nothing saying that you're not allowed to do that. And the reason that I like to do that is it reminds me that I have to do the inverse of that, which is subtracting 11 from both sides. And when we do this, again, this will cancel because 11 minus 11 is 0. We're still left with the 3x on the left, and then 17 minus 11 is 6. Now again, we'll go ahead and do the inverse of multiplication, which is dividing by our inverse of multiplying 3, which is dividing by 3 on both sides. We'll get that x is less than or equal to 2. Okay. Now, here's an example, again, where 0 is a really friendly number to try out. So I'm going to go ahead and substitute in 0 for this inequality and make sure that my solution satisfies and is a true statement. So I'll put in 0. And so 11 plus, well, 3 times 0 is 0, less than 17. And 11 is definitely less than 17. So again, you'll pick up these ways of figuring out which numbers will definitely help you out to make sure your solution works. Okay, let's go ahead to this next one. So we have 4x minus 12 is greater than or equal to 8. Now again, no fractions, just the same normal 2 steps. So your inverse of order of operations will tell you to do addition and subtraction first. Since 12 is being subtracted from x, we're going to add 12 to both sides. Okay, and again, this cancels out and it gives you that additive property identity of 0. Whenever we add 0 to anything, it doesn't change its value. So now we have 4x is less or greater than or equal to 20. And now we just divide both sides by 4. And we'll get that x is greater than or equal to 5. Okay. Alright, let's look at this next one here. Okay, so we have 3x plus 7 is less than 9. Okay, now what we're going to go ahead and do here is there's no fractions that we have to deal with, so we're going to go ahead and do subtract 7 from both sides because that's the inverse of adding 7 to both sides. And we'll get that 3x is less than 2. Now we're going to divide both sides by 3, and we're going to get that x is less than 2/3. And it's a fraction, no big deal. We're not always going to see whole numbers, truth be told. So don't let the presence of a fraction, even if in your original inequality you didn't see one, don't let that scare or intimidate you. We're going to start to see a lot of numbers that go beyond our whole comfort level with just whole numbers. So we'll have negative numbers, we'll have fractions. So just don't be afraid if you see an fraction as an answer for an inequality. It just means that all possible answers that work are going to be values that are less than 2/3. Okay, and again, you can try. Again, 0 is a great number to try. If you were to, actually, just to go ahead and show you, if you were to choose 1/3, which is less than 2/3, if I plugged in 3 times the quantity 1/3 plus 7 is less than 9. 3 times 1/3 is essentially 3/3. 3/3 is 1, plus 7 is less than 9. And 8 is definitely less than 9. So again, that's one of those examples where I wanted to show you where if you choose something really close, your inequality still is satisfied. It's just that the numbers are pretty close when you do your calculation to check your answer or solution. But this is going to be x is less than 2/3. Okay, let's go ahead and do number 9 here. So we see this one is very similar to number 4. So we have x/4 plus 1 is greater than 10. Now, again, we want to be careful with our order here, but because that addition of 1 is not part of the fraction x/4, we can go ahead and do that first. Because remember, this one is not, like I said, not to be redundant, but that 1 is not part of the fraction like it was in number 2. So this will be subtracting 1 from both sides, and we'll get that x divided by 4 is greater than 9. Essentially, just to show you what x/4 is, it's basically 1/4 times x. And when we are dealing with fractions at this point in mathematics, we don't like to divide by fractions. We can make our lives a lot easier by doing what's called multiplying by the reciprocal, which still is multiplying by the inverse. So because this 1/4 is essentially being multiplied by x, we would normally do the inverse, which is dividing by 1/4. But to make our lives simple, we'll multiply by 4. So as complex as that sounds, we're still seeing that x is divided by 4. So we're just doing the inverse of that and multiplying by 4. So we'll get that 9 times 4 on the right side. Again, this 4 times 1/4 will cancel out. X will now be by itself, and X is greater than 36. Okay. Okay. Let's go ahead and do another one. Okay. So now we're visiting this type of question again, where we see that the mathematical operation of addition or subtraction is part of a fraction. So we see x minus 6 over 4 is less than or equal to 2. Now this is one of those situations where we're going to go against the rules of going in the reverse order of operations, because the first thing that you want to do is get rid of that fraction or that divisibility of 4. So we're going to go ahead and multiply both sides by the denominator, in this case 4, and we're going to get that this will cancel, and all that's left is our numerator, and we'll get that x minus 6 is less than or equal to 8. And now we have just a regular plain field one-step inequality. We add 6 to both sides because that's the inverse of subtracting 6. And we'll get that x is less than or equal to 14. Okay. Now, here's something you can do with these ones. For ones that are equal to, go ahead and plug that value in directly. So if I plug in 14 minus 6 over 4 is less than or equal to 2 into my original inequality, 14 minus 6 is 8. 8 over 4 is less than 2, or equal to 2. And 8 divided by 4 is 2, and 2 is less than or equal to 2, and that works. So with those ones that say they're equal to, you can definitely plug in the corresponding value that your solution set is less than or equal to directly. So like for number 2 example, I could have plugged in 19 and it still would have worked. So just to give you some different options to explore. Okay, let me go ahead. Alright, so let's do this next one here. We have 7x minus 3 is greater than 18. Now again, there's no fractions here, so this is no problem, just 2 steps. So we're going to start by doing the reverse order of operations. Well, your first reverse one will be addition or subtraction. We're going to add 3 to both sides. And again, that cancels out the 3's on the left, so that's going to give us 7x is greater than 21. We'll divide both sides by 7, and we'll get that x is greater than 3. So just as a quick recap here, these 3's are going to add out, or they're going to cancel out because they're going to end up being 0. But the additive property of 0 tells us that when we add 0 to anything, that value doesn't change. Likewise with the second one, when we divide any number by itself to isolate a variable in this case, it's going to become 1. And the multiplicative identity of 1 tells us that if we multiply anything by 1, we remain that same value or variable, what have you. Okay, so this will be x is greater than 3. Alright, so we got one more to do here. Let's go ahead and knock this one out. So we have 3x plus 1 is greater than or equal to 7. And again, no fractions, no worries. We have minus 1, which is going to be the inverse of adding 1, which is subtracting 1. We'll subtract 1 from both sides of the inequality, keeping the balanced scale in mind. We have 3x is greater than or equal to, sorry about that, greater than or equal to 6. I'm going to divide both sides now by 3 because that's the inverse of multiplying by 3. And then we'll get that x is greater than or equal to 2. And again, I can substitute in 2 directly if I would like to for this one because it's greater than or equal to. If I plugged in 2, I would get 3 times 2 plus 1 is greater than or equal to 7. 3 times 2 is 6 plus 1 greater than or equal to 7. And 7 is greater than or equal to 7. Okay. Alright guys, so again, this is just some practice with two-step inequalities, just showing you sometimes that your structure of your inequality is going to look different, and just because it looks different, there are different ways that we can approach it. And again, my goal is to show you the most comfortable ways, the less tedious ways. So I hope this helps you folks out. Please don't hesitate to contact me if you have any questions. But as always, guys, please take good care of yourselves, and I hope to see you guys soon. Thank you so much for watching.